G'day from Australia. Thanks for joining me for part 2 of my series on building microservices with Node.js. I'll begin with the tradition we have here in Australia. I want to start by acknowledging the traditional owners of the land from which I'm broadcasting. I'd also like to pay my respects to elders past and present. My name is Ashley Davis. I am the author of Bootstrapping Microservices, and really happy to be talking to you today about microservices and Node.js. I'm going to share my screen with you. Stuff. So this is part 2 of a 3-part series of short talks that I'm giving. You can find part 1 on YouTube. I'm going to show you that in just a second. So I'll show you where to find part 1 in just a moment in case you missed that. And in the next couple of weeks, I'll be doing part 3 as well. So part 1 has already happened. Part 2 is what I'm doing today, developing microservices with Docker Compose. We're also going to touch on testing for microservices, although that's a huge topic, so we're only just going to really touch on it. I'm also going to show you how to add a database to the development version of our microservices application. And coming up in a couple of weeks, there'll be part 3 of this series where I'm going to show you how to deploy microservices to production, running on a production Kubernetes cluster. And we're also going to look at how to deploy a database to production and more advanced communication patterns for microservices using RabbitMQ. Please feel free to get in touch with me later as well. You can see my email and my Twitter handle on every slide here. So please feel free to reach out to me, get in touch, and talk to me about tech and microservices. Before we get into the good stuff, I'll just tell you a little bit about myself. I'm the CTO of Sortle, and we have a product that helps you manage your, organize your digital assets through the magic of machine learning. I'm also the developer of a product called DataForge Notebook. It's like Jupyter Notebook for JavaScript and TypeScript. You can prototype your code with live visualizations and later export your code to run in production. I've written 2 books with Manning, Data Wrangling with JavaScript, which is my first book showing JavaScript developers that they probably don't need Python. Most of what you need for working with data is already available in JavaScript. You just need to learn how to use it. And of course, my latest book, which is Bootstrapping Microservices. I'm not doing a book giveaway today. If you come back for part 3 of the talk, I will be doing book giveaways. I will be doing book giveaways next Monday night at BrizJS as well, if you can attend that. But please hang around to the end of this talk today and I'll give you a discount code. Bootstrapping Microservices, it's a practical and project-based guide to building applications with microservices using all the latest tools and focusing on Docker, Kubernetes and Terraform. This is a book that will take you all the way through from building one microservice all the way through to deploying a complete microservices application to production. Starting off simply using Docker to package and publish, ramping up to multiple microservices and simulating a microservices application in development using Docker Compose, and eventually you're creating a Kubernetes cluster and deploying our applications to it using Terraform. So you get all this in the book. And the content you'll see today and in this whole series, it's very much related to the book. So if you like more of what if you want to get more of what you see today, please grab the book. Let's get into it. So in this talk, part 2 of my series, I'm going to show you how to scale up your development environment for developing and testing with multiple microservices. And I should say that this isn't really specific to Node.js. Because we're using Docker and Docker Compose, we can practically use any tech stack. And so I personally use Node.js and JavaScript or TypeScript to develop microservices, but you can use any language you like, really. And and what I'm demonstrating today will be microservices on Node.js, but the focus is Docker and Docker Compose. So what you're getting today is generally useful, even if you're using a different programming language or runtime environment. Now, before we get to some new stuff, I just want to review what we covered in part 1 about why we should use microservices. Now, again, I covered this in detail. Actually, I didn't show you. Let me just show you where you can find part 1 of this talk. So if you go to my web page, my YouTube page, the Data Wrangler, you can find Building Microservices with Node.js Part 1. Today's talk, part 2, will be up on YouTube soon, and in a couple of weeks we'll have part 3 up here as well. Please take a look at that. So this is just a summary of basically, why we should use microservices. And again, just if you want to see this in more detail, please see part 1 of this talk on YouTube. Microservices are all about complexity management. We shouldn't fear complexity. What we need as developers are better tools to help us manage complexity, and that's what microservices are for. They help us manage the ever-growing complexity of modern applications. Microservices give us fine-grained control over security, scalability, team structure, deployment, and so on. Microservices allow us to isolate faults. So if a problem happens in a single microservice, we can contain it there, and it doesn't have to affect other microservices, and it doesn't have to cause an issue for our customers. Microservices allows us to minimize deployment risk. When we break a microservice, we risk breaking only a small part of the whole, so our risk is lowered compared to working with a monolith. Microservices support a scalable team structure, and microservices support scalable and fine-tunable performance. And this is my favorite, this last one. Microservices can help us control technical debt. We can isolate technical debt into little islands, and because microservices are so small and they can be rewritten quickly, that means we can iteratively replace our application over time, replacing all the technical debt with better code. So that means we can prototype quickly and even build MVPs. And we don't have to worry so much about, the quality of the code because we just replace it later. Now we're about to upgrade our development environment to support easily running multiple microservices. And this brings us to the question, what are the development needs for microservices? We talked about, in part 1, we talked about the development needs for a single microservice, but now we're scaling up to multiple microservices. To start with, we need to be able to build and run and test a single microservice, so we've covered that. Covered that in the last talk. I even did a live demonstration of creating a really simple basic Node.js microservice from scratch. We still need to talk about how to test a microservice. We haven't covered that yet, so we'll talk a bit about that today. To have an efficient development cycle, we need live reload at the level of the single microservice. And I showed you how to do that in part 1 of this series. That means we can basically be coding away and have our microservice or even our automated tests automatically reloading as we're coding. So we got that set up for individual microservices. We can basically do everything for a single microservice, and that's a great starting point. That's what we need to build a microservice in the first place. But we also need to come back to this point whenever we want to kind of test or debug a single microservice. But we need to scale up because it's not really a microservices application if we're just working with individual microservices. We need basically a way that we can build, run, and test multiple microservices, an entire application. And we also want to have this live reload applied across our whole application as well. And of course, live reload, it's for development only, it's not for production, but it's really important in development to have a fast and effective workflow. Now, we'd like to have multiple microservices running, and when we change code for any of them, we want only that single microservice to be automatically reloaded. So it's got to be smarter than restarting the entire application. Now, in part 1 of this talk, I explained, why I like to use Node.js and JavaScript to build microservices. And in this part of the series, I'd like to explain, why we should use Docker. First of all, you've probably noticed this, Docker is everywhere. It's an increasingly common standard, and it's worthwhile knowing just because it is everywhere. But practically speaking, what does Docker do for us? To start with, it's one of those tools that allows us to do infrastructure as code. And I like to think of the Docker file as a script for building a microservice. I want to reiterate as well that Docker is technology agnostic. That is to say that you can embed any tech stack within a container. And if you're using Docker, it means that you can use whatever language you want. I like to use Node.js and JavaScript. You can use any other language you like. One of the most basic things that Docker does for us is it allows us to standardize our environment. We can make sure we're using the same development environment as our teammates, and more importantly, we can make sure we're using the same environment, the same setup as our production environment. Now, this next one is the most important factor for me. Docker allows us to package our microservices. I like to think of this, I like to think of Docker as the universal package manager, because it's the one thing that we can use to like package pretty much any language or any tech stack, including all its dependencies. And if Docker didn't allow us to bundle our microservices or bundle our code and dependencies, the rest of this stuff wouldn't matter. So the ability to package, I think, is the most important. And leading on from that, obviously, once we've packaged it, we want to be able to publish our microservice to a container registry. This is a vital stepping stone for basically getting our microservice to production. Now we're not going to look at getting to production today. We're going to look at that in part 3 of this series. But just know that Docker is a vital stepping stone in getting our microservices into our production environment. Ultimately, we want to run our microservices, and Docker is useful for this, at least in development. I'm going to show you in a moment how to run a microservices application in development. For production, I like to use Kubernetes. We're going to talk about that in part 3 of this series. But what I will say now is that Kubernetes is actually moving away from Docker and towards like an open standard for container runtime. So technically, speaking, in the future, Kubernetes won't use Docker, but it is going to use something that's very much like Docker. In fact, an open standard that evolved from Docker. So we're going to use Docker to package and publish our microservices. We're going to use Docker in development to run our microservices. But in production, we're going to use Kubernetes. And that may or may not have Docker under the hood, depending on what version of Kubernetes that you're running. So now that brings me on to Docker Compose. Why is it important? Well, firstly, it's super convenient to be able to essentially declare an entire microservices application in one file. This helps us to build a scalable and efficient workflow. So just imagine you've got 10 microservices in your application. To run this application in development, you have to invoke Docker build and Docker run, for each microservice. So that's about 20 commands you've got to run. And imagine having to run this multiple times a day to kind of, bring your application down, rebuild it, restart it. As you're going through your working day, doing development, restarting the application. It's really painstaking, and it's not a good way to work. So Docker Compose, what it does is it's a command that allows us to convert many Docker commands into a single command. So we're going to be using the up command. I'm going to show you this in a minute. We're going to use the up command to bring up the application. We're going to use the Docker Compose down command to bring down the application, and so on. There's a bunch of commands that Docker Compose gives us, for working with our application as an aggregate, rather than just using Docker individually to work with each of the microservices. Now, the other thing Docker Compose does for you is it records all of the configuration for all of your microservices. So these are the things that you would normally have to type in on each time you invoke Docker build and Docker run. So it records all that for you. You don't have to remember it. You don't have to retype it. It's just there waiting to be reused. Docker Compose, it's another tool that allows us to do infrastructure as code. And I like to think of it as a script to build and run our entire microservices application. So whereas Docker was a script, basically, a Docker file is a script just for a single microservice, Docker Compose is a script for a complete microservices application that ties together all the separate Docker files. Now, personally, I use Docker Compose for development only. I don't use it in production. And this is simply because I prefer Kubernetes for production deployments. Kubernetes is a robust, flexible, and scalable solution for production deployments. So the question should be really is, why don't I use Kubernetes for development? And people have asked me this. And the simple reason is Kubernetes can be quite difficult to set up. It's easy to run in the cloud, of course. If you're creating it through your cloud vendor's UI, it's just a couple of clicks usually, at least on Azure. If you're creating it through your cloud vendor's CLI tool, it's not much effort. It's very easy to create a managed Kubernetes cluster running in the cloud, but it's much more difficult to set up locally. And you could try something like Minikube. I've never really tried that for development. Or if you've installed Docker Desktop for Windows or Mac, it actually comes with Kubernetes. But when I tried to use it, it kind of almost killed my laptop. It's very heavyweight. Would probably be good if you want to experiment with Kubernetes on a desktop computer, but I like to always be mobile and be able to run my applications on my laptop when necessary. And Docker Compose, it's just really nice. It's really convenient for development. It makes it real easy to manage and maintain a microservices application running on your development computer. But ultimately, I don't think Docker Compose is suitable for production. But your needs may vary. So please feel free to look at that if that interests you. Okay, it's time to look at some code. If you could just commence your prayers to the demo god that this all works seamlessly, I would be very much appreciative of that. Okay, so I just found my terminal. So I've got a terminal open here. I'm running on Windows 10, but I've got Git for Windows, which gives me all the lovely Linux commands. Now I'm just running out of an example project from my book here. I'm going to show you where to find this in just a second. And I'm going to give you a bit of an overview of the code and how all the microservices here fit together and how we start these in development. Because it can take a moment to actually start it running, because there's multiple microservices here, I'm just going to start it running now. And then we'll come back and we'll kind of look at some of the code while it's booting up. Before we start, I'll just show you that I've got Docker installed. So I've installed Docker Desktop for Windows, and I'm using the WSL2 Ubuntu backend to run it. It takes a bit of effort to get that set up on Windows, but it's really worthwhile if you use Windows. For you to be able to use Docker, you need it. Or you could run Docker in a virtual machine. I used to run Docker under a Vagrant virtual machine, but I haven't needed to do that since I've started using WSL2. And of course, if you're on macOS, Docker Desktop just installs without any other setup, and it's really easy to use and seamless to use on macOS. I've also got Docker Compose. So Docker Compose comes with Docker in Docker for Desktop. If you're running this on Ubuntu Linux, you probably have to install Docker Compose separately. So just be aware of that. If you've already installed Docker, you probably don't have Docker Compose if you're on Ubuntu Linux, or sorry, just Linux in general. So now I've got what I've got in here is the important file here is the Docker Compose file. So that's the script I was telling you about. It basically ties together all the Docker files for all the different microservices. And when I run Docker Compose up, it's automatically going to read that file and boot up all those microservices for me. What I do though usually is put the -- build argument on the end here, and that forces it to build all the Docker images from scratch each time I run this, which basically means it's going to pull in any updated code or anything, any updated dependencies, stuff like that. So this is going to take a moment to start up. While that's starting up, I'm going to show you what the application looks like. So this is actually an example application called FlixTube from my book, Bootstrapping Microservices. It's a sort of an ongoing example all the way through my book. What we're looking at here is a microservices application, running on a development computer, just any old ordinary PC really. It's running under Docker Compose. It's a gateway microservice, so that's what allows the outside world to connect in and kind of look at FlixTube through a browser. This is a video streaming application, so you can see sort of video related microservices here. Microservices for managing metadata and history, microservice for managing video storage. I'll talk more about that in a moment. So FlixTube is like just a fun little app that I made up. It's it's kind of like meant to be like a combination of YouTube and Netflix or something like that. It's the world's next big video streaming platform, right? Not really, but it's a good little example for the book. It's not too small, it's not too big, and this is what the example looks like in chapter 9 of my book as well. So we're kind of jumped forward in my book to quite a complex example here. So just bear in mind that when you start reading my book, we start with a single microservice. That's the video streaming microservice. And then we work up to getting, a couple of microservices working, getting a database in there, getting cloud storage, working up to a multi-microservice application using Docker Compose, and ultimately getting it into production. But because we're looking at an example from chapter 9 of my book, it's going to be a little bit more complicated. But just if you do look at the early chapters of the book, it does start out much simpler than this. But the reason I wanted to show you FlixTube at this stage was just to show you, to really nail at home what Docker Compose can do for us, because what we normally have to do here to run this application in development is we'd have to do like we do this two ways. We're using Node.js, right? So we'd have to run 1, 2, 3, 4, 5, 6. We've got 6 microservices, so we'd have to open 6 terminals and run 6 instances of Node.js to get all these running. That's not too bad for 6 microservices, I suppose, but it gets worse as you get more. But if you want to run it and test it using Docker, that's where the problems come in really, because you've got 6 microservices, and if you want to build and run all those, that's like 12 commands. So that's a lot. But I've booted this whole thing just using the one command, docker compose up, and now we've got this booted up. And I can show you the front end. I'm just going to load up the front end. So the gateway microservice includes, an ultra simple front end. From memory, it's on localhost 4000. So this is the UI for FlixTube. Really simple. There's no videos yet, but we can upload a video. We could upload that. In fact, I'll just do it. I'll just go through the process. Where are my test files? Okay, here's a sample video I'm going to upload. It's only 1 megabyte. It uploads almost instantly. It says here it's uploaded. I can look at the videos now and I can see it there. I can play it. So, I've got a simple video streaming platform built as a microservices application. Now, when I'm finished with it, I can run one command to bring it down. And that's docker compose down. Or I could run docker compose ps first to see what's actually running. So this shows us all the containers that we've got running. So you can see that we've got a bunch of microservices running here, but I'll close it all down. So this is terminating the entire application now. Well, I don't want to do that. I do want to have this running so I can show you some testing, automated testing against it in a moment. So let's start it back up again. Now the video that I just uploaded is going to be gone because I basically just destroyed the application by using the down command, and I'm restarting it now. Anyway, I'll show you where to get this code as well. So if you go to my Git organization, Bootstrapping Microservices, you can find the Chapter 9 code repository here. And you can grab the code for yourself from here. So just remember, Bootstrapping Microservices Chapter 9, you can get this code. Like all you need to run this example is to have Docker and Docker Compose installed on your computer. Come here, get the command here or the URL here for cloning the repository, clone it locally, and then run Docker Compose up, and you'll have the example version of FlixTube that you can play with, including the Docker Compose file. So let's actually have a look at what this looks like. So I've got another terminal open here. I'm going to open Visual Studio Code on this directory. Let me just bring it on screen. Zoom in a bit so we can see what's going on here. I'll just close everything here to start with, just so we can have a look at what's actually in the project. So you can see here there's a bunch of subdirectories for each microservice. This is all in the same code repository. That is just for convenience, really, and simplicity of the demonstration and the example. Ultimately, to be able to scale a microservices application, you need to basically factor out all the microservices into separate code repos. So just be aware that this is a little bit more simplistic than that, but that is what you'd have to do ultimately. And I talk about how you can do that in the final chapter of my book, how you can kind of start simply in one repo and how you can factor out to like a meta repo later. So what we've got here is we've got the Docker Compose file in the root directory. So let's open that. Now, a Docker Compose file lists all the services. So under the services field here, you can see the database. You can see there's a RabbitMQ instance. There's something here for database fixtures. I'll talk about that in a moment. And then we get onto all the microservices. So we've got the gateway microservice. We've got the video streaming microservice. All the different microservices that I showed you in that diagram a moment ago, they're all here. You can scroll all the way down to the bottom. There's the video storage microservice is replaced by a mock. So the real video storage microservice stores our videos in Azure storage. But there's a mock one here, and I'll talk about mocks in a moment. So we'll come back to that. Now let's look at the example of the gateway microservice here. It's this whole section here. This is the interesting bit here on what's building here. So we're saying in the context of the gateway subdirectory, see that hopefully, the context of the gateway subdirectory, build the development version of the Docker file. So if we actually look down in the gateway subdirectory, you can see here, there's a development Docker file and there's a production Docker file. And the reason I have two of those is because the production Docker file here bakes the code in. You can see here, we're copying the source code over, but in the development Docker file, we don't copy the source code. We literally just copy the package.json over. And I'll show you why that is in just a second. So under the volumes here, you can see that we've wired the code through. So we're saying that the source directory is basically wired through from the host operating system, from the development PC into the container. So we're sharing the code. So anytime we edit the code on our PC, anytime I edit the code here in Visual Studio Code, it's going to actually just get wired straight through into the container. And then what we do in the Docker file is, instead of running the usual npm start, we're running npm start dev here. You might remember back from my first talk where we kind of set that up in a microservice, and we set up live reload. So you look at the start dev command here in the package.json for the gateway, and it's running nodemon. And so nodemon is basically what runs the microservice, but restarts it whenever the code changes. So there's two parts to this. One is using nodemon, which we covered in part 1 of this series. So go back and have a look at that on YouTube if you want to kind of refresh on how that works. And then in the Docker dev file, we're running, that start development command. And in the compose file, we're sharing the source code. We're sharing the source code into the container. So this is the same configuration, the same setup for every microservice. So whenever we change the code for any microservice, that's automatically synchronized through to the container. And then nodemon reboots the microservice. So that's all good and well. Okay, so what else do I need to show you here? I'll come back to the database fixtures. I'll come back to the mock storage in a moment. I think that's basically all I wanted to show you here. Trying to think if there's anything else that I needed to show you just in the Docker Compose file here. I mean, that's the essence of it though, right? So, oh yeah, I was going to show you the database deployment. So you can easily instance any kind of server into your application just by telling it which image to run. So this is running booting up a container from the Mongo 4.2.0 public Docker Hub image. And we've got a bit of configuration for that here. So that gives us a database server. And even though we want to follow the rule, it's really quite important for scalability in the future to follow the rule of always having one database per microservice. That doesn't mean we can't just have one database server. So we've got one database server here, but every separate microservice is configured to have its own database on the server. So one database server, multiple databases. While we're here, we've also got RabbitMQ. So we're using RabbitMQ to do kind of asynchronous messaging between microservices. It's a message queuing software system. But again, we're just kind of booting it off a publicly available image. And I'm actually going to talk more about RabbitMQ in part 3 of this series, so coming up in a couple of weeks. But this is how you instance any kind of server really into your microservices application. You might want MySQL, you might want Redis, and any kind of thing, kind of pre-existing, publicly available server that you can think of. It's just, this many lines of code away from being included in your microservices application, which I think is pretty cool. One thing you might be wondering here is, why do I have restart always set for these servers, and but why do I have it, for the gateway here? Why do I have it set to restart no? Well, that's simply because if I had my gateway, if I had any of my microservices that I've written the code for, if I had them automatically restarting if they crash, it means I might not notice problems. So I want these things, if they crash, to not be restarted, because I want to notice that they've crashed, and I want to be able to go and see what the problem was and fix it. Now that's kind of like the opposite to what you want in production. When you're running this kind of application in production, you want you want all your microservices, all your things to automatically restart if they fail or if they crash. But you also want the crash and the errors to be reported so you can go back and look at it. So for production, you want it to always restart. For development, I say don't let it restart. But it's a little bit different for, like, say, MongoDB, which I've got set up to always restart. Only because, if MongoDB did crash, and it's pretty rare that something like MongoDB or RabbitMQ crash. If any of those things crash, it doesn't matter. Like I can't do anything about that. I can't go and debug it and fix the code for the database. It's not my code. So I just set that to restart because if there is a problem with it, I don't want to know about it. I just want it to keep going. Cool. So that's about all I've got to show you for the moment in the Docker Compose file. What I do want to talk about now is a bit about testing. Now I'm just going to touch on this because testing microservices is pretty much, in a lot of ways, it's the same as testing any code, right? I'm going to show you a demo in a moment, a demo specific to the way I like testing microservices. But first, let's just understand first a bit about the different types of testing, and how they might be, how they might apply to microservices. To start with, some kind of testing is definitely needed. Like whenever you're building an application, writing code, you've got to do some kind of testing, right? Otherwise, you don't know if it's going to work. And it's perfectly okay to apply manual testing to microservices. Typically you want to trigger actions in microservices like by HTTP request, or by sending a message in a message queue like RabbitMQ or something like that. So you can trigger HTTP requests manually by using something like Postman or VS Code REST client. Or you might want to build your own testing tool if you want to be able to feed messages to microservices. Or if your microservice includes any kind of front end, like what I showed you before with FlixTube, we used its front end to upload a video. We were just doing some manual testing of FlixTube just back then. So if you've got a front end in any of your microservices that you can access, that's a way to test it. Manual testing, it's a great way to start. If you're learning microservices, don't jump straight. If you're learning any kind of coding, don't jump straight to automated testing. Stick with manual testing until you're comfortable with that before you try and learn automated testing. And also, if you're an experienced developer and you're prototyping like a new product, or you're trying out a new business model, you're probably not ready to invest in automated testing yet. So just hold off, until you're satisfied that you can make the investment. But you're basically making a long-term investment in your code if you go to automated testing. And also, exploratory testing is always going to be necessary. That's where you're kind of exploring your system to find out the problems that the developers never even thought of. So, some form of manual testing is always going to be necessary, even after you've upgraded to automated testing. So manual testing, though, it's like, generally speaking, it's not very scalable. And for a small team to be able to manage a growing or large application, we need to be able to invest in automation. And as our application grows large, we're going to lean more and more on that automated testing to ensure that the application continues to function as we evolve and extend it. The diagram we have on screen here is called the testing pyramid. You might have seen this before. This shows us the main types of automated tests that we can make use of. At the top, we've got end-to-end testing, and it occupies the smallest area of the pyramid. But that indicates basically that we should have the least amount of these tests. And the reason for that is these tests are really slow to run. So, the more of these tests you have, the longer you're going to wait to see the results or get the feedback from a test run. But having said that, end-to-end testing, I find it to be one of the most productive forms of testing because it usually means you're testing from the point of view of the customer. And that's the most important perspective that you can take, really. And also, end-to-end testing, it covers a lot of code at once. So you get a lot of bang for buck. But unfortunately, it can be very difficult to apply end-to-end testing to microservices applications, especially as they grow larger. Now, it's perfectly feasible to use end-to-end testing on a small or new microservices application, and that's a great way to get started with a new application. The problem is that as you add more microservices to your application, it becomes harder and harder to instantiate the full application on a test PC. So as your microservices application grows, it's basically becoming too large to fit on your testing PC. So end-to-end testing is becoming more and more difficult as your application grows. There are ways around this. One is that you could do your end-to-end testing against a test cluster instead of a development computer. And or you could, if you still want to run your microservices application on a development PC or a single testing PC, you can create cut down versions of your application by creating like customized versions of the Docker Compose file. Chopping out any microservices that you don't want to test and leaving in the ones that you do test. So you could have multiple configurations of your application set up for end-to-end testing for different features that you want to test, and you can test them at different times. So end-to-end testing is harder as your application grows, but there are ways around that. The next step down the testing pyramid is integration testing, and it's got a smaller area a larger area on the testing pyramid. And what that means is that you should have more of these tests than end-to-end tests, and that's typically because integration tests are going to run a lot more faster, hopefully, than your end-to-end tests. And I think integration tests are actually particularly effective against microservices, because typically you can run your integration tests against the HTTP API, the REST API for your microservice. Or you can run it against the message queue for your microservice. So particularly effective. You're still testing a lot of code. You're not testing the front end. You're not testing multiple microservices. You're just testing a single microservice at a time, but you're testing all the code in that microservice. The last step down the testing pyramid is unit testing, and this is the most granular form of testing, and it occupies the largest area in the testing pyramid because this is the type of test that you should have the most of, more than end-to-end tests and more than integration tests. Now, unit testing, it's like exactly the same for microservices as it is for any other kind of application or code. So, like there's not a huge amount for me to say here. But what I would like to say is that opinions about unit testing in the industry are generally very mixed. Personally, I really love unit testing, and I would love to see all code, covered by unit testing. But actually, realistically, that's not the case, because unit testing requires a really large investment in time and resources to create and maintain the unit tests over time. So as a development team, you need a lot of discipline to stay on top of it ongoing. And from a practical point of view, much of the code that you write, it may not be worth the investment in unit tests. I would say that most of our code is probably best served by integration tests. So having a large amount of integration tests with a handful of end-to-end tests, and then saving the unit tests for your most important code, for your most reliable code, or the code maybe that's changing the most frequently. This is going to be a difficult call to make, and it really depends on it's like a value judgment really that you're going to have. It's going to be different depending on your team and your company. So that's all I have to say at the moment about the main forms of automated testing, but there are a couple of more types of testing that I think can be applied well to microservices. And the first is what I like to call output testing, although you might have heard it called snapshot testing. And in terms of microservices, this means automatically capturing the output of a microservice during a test run, and then automatically comparing that output to a previous working version. And then if there's a difference, you raise an alarm. Because something's changed and potentially you didn't want it to change. Potentially it's a bug. So, output testing, it's a really cheap and effective, efficient means of testing. It's a bit like integration testing, that you're testing the entire microservice, but you don't have to write much code to achieve it. So it's really cost effective. The last form of testing that is useful is called contract testing, and this is what verifies the flow of messages between two microservices and conforming that it conforms to some established contract. Now, if either party in the communication breaks the contract, we'll automatically be informed of it. So there's a tool called Pact, which I've heard is really good. And I think contract testing can be, really, really useful. One of the probably more robust and scalable ways to test groups of microservices. As your application grows, it's going to get much more important to be able to do this. These are some of the testing frameworks that I recommend. For new projects, I tend to use Jest, and some of my older projects still use Mocha, which I still think is a really good testing framework, and I'm still happy to actually continue using it. Cypress, I'm going to give you a demo of Cypress in a moment. It's a fantastic tool for end-to-end testing of UIs. You can do integration testing with it as well, so you can do integration testing of microservices, but actually I prefer just to use Jest to do that. But for testing front ends, and you can either have the full backend in place, or you can kind of mock the entire backend. So just using Cypress to test an isolated front end. really awesome. And also I mentioned Pack, so that's a really good tool for testing contracts and communication between microservices. And don't be afraid to kind of build a do-it-yourself testing framework as well. If you need something that's different to what you can get in the existing testing frameworks, write your own code. Like I often write test beds to test, unusual features of microservices that where it's easier to write some custom code, write not a general purpose framework, but write a very specific little test bed for testing a single microservice. This can actually be really useful as well if you want to kind of say feed messages into a message queue to your microservice, like build a test bed that allows you to feed messages into RabbitMQ, say. So do-it-yourself testing is also really useful for output testing. So what I talked about in the last slide. Use you might have to build your own system basically if you want to do output testing. Now, I just want to mention building abstractions with microservices because it can be really useful for testing. Of course, microservices are great for building abstractions. Where you want to take something complicated or something that you might want to change later and, wrapping it up behind a simpler API. On screen, you can see an example here. This cloud storage microservice here is a way to abstract your cloud file storage, behind a microservice. And so the rest of the microservices application interacts with this simple API, and it doesn't really matter then whether your backend is, like an S3 AWS bucket or, Azure Cloud Storage or Google Cloud Storage or whatever it is. You have freedom to change this backend without affecting the rest of your application. But this is also really good for testing, right? So you might have noticed how I had like a mock storage microservice in FlixTube. So basically, we're replacing the real storage microservice with the mock version, and the mock version implements the same API, but in this case, because it's storage, it's just going to store the files in the local file system. Now, this being able to mock whole microservices like this, I'm not talking about making fun of microservices either. If you haven't heard of mocking before, mocking is replacing the real thing with a fake thing. And in this case, we're doing it because we want to make the development version of the application, simpler, more efficient, isolating it from external resources. But this is really essential for testing, where you really want to have the whole application running locally and not making external calls to services, that could conflict with other test runs or other developers doing tests and using that kind of same storage service. So really, really essential for testing. And also earlier I said, it can be quite difficult to do end-to-end testing for large microservices application. Mocks is one way that we can kind of cut down the size of our application to make it more amenable to end-to-end testing. So we can replace large complex microservices with these tiny, simple mock ones. Or if we've got one microservice that's like a gateway or an abstraction over multiple, like a whole family of microservices, then we can replace that whole set of microservices with a mock version. So you can use this technique to really cut down the size of your application. Now, I'm just going to quickly switch back to the code just to show you how the setup for the mock microservice looks. So we're back in Visual Studio Code here. I'm just looking for the storage microservice. Here we go. So this is the commented out storage microservice. So it is using the Azure storage microservice. So that lives in the project here under Azure Storage. So under here is the code for the real microservice. But instead we've commented that out, and on the same port number, so we've got it mapped to port 4005 on the host PC. We've got basically the same named container, video storage, but we're mapping it to the mock storage subdirectory here, the microservice that's in mock storage. So this is literally just a copy of the Azure storage microservice, but it removes any connection to the outside storage service, and it's only just going to be storing files in the local directory. So I can test this application with either, I can use Azure storage, or for the convenience of local testing, most of the time I would have the mock storage microservice enabled. Now, the other thing that's worth a mention for testing is the use of database fixtures. So a database fixture is a known piece of test data that you can preload into your database so that it's ready to be tested. And even if you aren't doing automated testing, like if all you're doing is manual testing, it's still really useful to have database fixtures. It can be useful to have database fixtures even if you just want to demo your application to a potential customer, like you can load up a particular data set that makes your application look really good, and then show that to your potential customers that you're trying to bring on board. Now, typically I incorporate database fixtures into my Docker Compose file. I'll show you that. I'll go back to the code in a second and show you that. But what that means is that I can boot up my microservices application in just moments, and right from the start, I've got the ability to kind of inject sets of test data in it, and it's just a great way to be for development and testing, but it's also really essential for doing end-to-end testing, which is what I'm actually going to show you in just a second. So I've got a service right near the start here called the Database Fixtures REST API. So I won't drill down into the details for this, but just be aware that this is like it's essentially a separate microservice. We don't run this in production. We just run this in testing or development. It's like a REST API over our database that allows us to load new sets of data in. And I'll just show you now the set of data that I'm going to load in for the test. I'm going to show you in a minute. Under the fixtures directory here. So there is only one test and one database fixture, because this is just a real simple example. But this is an example of a database fixture that's going to load 2 videos into our database. So there's an array of data, and each object represents a video. It's got a database ID and it's got a name. I mean, that's all. I mean, you can go really far with large sets of data that you can load, but this is just a real simple database fixture that we're going to load into the database through our automated testing, and using this database fixtures REST API to load it. So you can find the code for this if you want to look in the code repository on here. This REST API actually lives on my GitHub page as well. So if you look under GitHub Ashley Davis and look up the database fixtures REST API, you'll find the standalone code for this if you want to use it in your own projects. Okay, so we're actually going to look at some automated testing now. So from the demonstration I did earlier, you will see that I've got the application still running here under Docker Compose. I've got a separate terminal here. Now I can run, I've got this set up in my package file so I can run npm test to do headless testing. So this will run, I've got one single end-to-end test to show you. Not a very complicated example, but it's easier to understand because it's small. npm test would run that in headless mode just from the command line. But what I want to do instead actually is run test watch, which actually is running Cypress open. So Cypress, really easy to get started with. If you want to install Cypress, you run npm install Cypress to get it into your project. It's a pretty big package, so be prepared for it to take some time to download. And then you can open the user interface, and it shows you all your test files. So I've only got one. And when you open a test file, it's going to show you, let me zoom in a bit. It's going to show you all the tests. We've only got one test, and it's going to run automatically, and it's running against the application that I've got running under Docker Compose. So you could just as easily run this under like against a test cluster. So if you had your application, your microservices application deployed to a Kubernetes cluster, like a test version that's not customer facing, that would be an appropriate place to run tests as well. So you can see that I've got a test suite here. I've got one test. You can see here where it's running through some requests to the database fixtures REST API to load the test data. And then it's visiting the homepage, and you can see in the homepage, you can see it here. This is what I love about Cypress, is it's very visual, and you can see it running through the tests as it's going. So so it's basically what it's done is it's injected the test data. It's gone to the root page of the website, and it's displayed that it's got 2 videos in the database. It's then doing like a get against that video list div, and it's basically checking here. You can see on the right there, you can see as I hover, what aspects of the page that it's testing. So it's just testing that what we expect to see in the front end is going to be there. So this is just this isn't just for microservices. Obviously, this is a great way to test any front end. But this is one of my go-to tools for testing complete microservices backends and the front end. And like I said, you can completely in your test code, which is all the test code for this is in JavaScript. I'll show you that. So the test code is written in JavaScript, fixtures, no. Integration test, here we go. So this is the simple test code here, where it's basically, it's got the test suite, got the one test can list videos. We're loading a database fixture called 2videos. That was the JSON file we looked at a moment ago. We're visiting the main web page, and then we're basically pulling out elements of the page and testing what they've got. So if you want to, you could set up in here to mock the back end. You can actually mock out REST API calls to the back end. So like I love this idea. I haven't really made use of it myself yet, but I love this idea of potentially being able to do test-driven development, front-end development, by being able to completely mock out a back end that doesn't even exist yet, and do test-first coding of front ends. So that's a little bit about Cypress. Please go to the website. Where is it? I've got it up here somewhere. Cypress.io is the website. Go and have a look. Watch the videos here as well, because like my demonstration that I've just done doesn't really do it justice. But if you go and click play on this first video, I would be surprised if you weren't impressed with what Cypress can do. Like, it is an amazing piece of testing toolkit. That's about all I've got time for today. So this has been part 2 of my series on building microservices applications with Node.js. Today we've talked about Docker Compose and a bit about testing. There's more to talk about, heaps more to talk about, coming up in part 3 in the next couple of weeks. Feel free to follow me on my Twitch channel. I'll do that. So you can find me Ashley Davis on Twitch if you want to find out when the next one is being streamed. Or check my YouTube channel. Getting a bit of feedback there, sorry. I'm not sure where that was coming from. Something live going on Twitch there. Yeah, so I'm on Twitch, Ashley Davis. I'm on YouTube at The Data Wrangler. I'm on Twitter at Ashley Davis 75. So look me up wherever you can to find out where the next talk's going to be, where you can watch it. We're going to be talking about, in part 3, we're going to be talking about RabbitMQ and indirect messaging, show how to deploy a database to Kubernetes. We're going to talk about automated continuous delivery, automated testing in the continuous delivery pipeline, and the real crux of it will be deployment to Kubernetes. So deployment to a production Kubernetes cluster. So I'd just like to leave you with a link to my book, Bootstrapping Microservices. Again, this is a practical and project-based guide to learning microservices. It's going to take you all the way through from a single microservice to having multiple microservices running in production. There's a discount code on screen for 35% off. Please make use of it, and I really hope you enjoyed the book. And thanks so much for listening. I hope to see you again in part 3 of this series.